somewhere in the Pacific Ocean, a sockeye salmon is swimming in circles. Not lost. Searching. It hasn't eaten in days. Its body is burning through the last of its fat reserves. And yet, something inside this fish is pulling it toward a coastline it hasn't seen in 4 years. Here's the impossible part: among thousands of rivers draining into the Pacific, from Alaska to California, this salmon will find the exact stream where it was born. Not a similar river. The same one. The same gravel bed. The same cold water. How does a fish carry a map it cannot see? The answer is hidden in something even stranger, a memory made of smell, magnetism, and time, written into its brain before it ever left home. This is the salmon's impossible climb. And it begins not with the journey back, but with the first breath of home. The Fraser River, British Columbia. Late spring. Beneath the gravel of a cold tributary, thousands of sockeye salmon eggs are hatching. The embryos, called alevins, are barely 2 centimeters long, still carrying their yolk sacs like tiny backpacks of survival. They won't leave the gravel for weeks. But already, something critical is happening inside their developing brains. The water flowing through these stones carries a unique chemical signature, a blend of minerals, organic compounds, dissolved gases, and traces of the watershed's geology. No 2 rivers smell exactly the same. And during this fragile window, the young sockeye salmon is recording that scent. Scientists call it olfactory imprinting. Evidence suggests the process is time-sensitive. Miss this window, and the fish may never form a reliable map home. But smell alone isn't enough. Recent research points to a second system, one that operates on a planetary scale. As juvenile sockeye salmon begin migrating downstream toward the ocean, they may also be encoding the Earth's magnetic field at key waypoints. A kind of internal compass, calibrated to latitude and intensity. 2 invisible maps. 1 biological clock. All written before the fish is old enough to survive a single day at sea. The young sockeye salmon will spend up to 2 years in fresh water, feeding, growing, dodging predators. Then, when the timing is right, it will undergo a transformation called smoltification. Its body chemistry shifts, its kidneys adapt to salt, and its silver scales harden for the ocean. It remembers nothing of the sea. But something deeper is already pulling it forward. The question is, will the river it memorized still exist when it tries to return? The North Pacific. Open water. Far from the coastline, the sockeye salmon enters a world without landmarks. No riverbanks. No current to follow. Just blue in every direction, and predators circling below. Out here, the rules change. The fish that once hid among rocks now swims in vast, shifting schools. It feeds aggressively, herring, squid, small crustaceans, building the fat reserves it will need for a journey it doesn't yet know is coming. Growth is rapid. A sockeye salmon can double its weight in a single year at sea. But survival is not guaranteed. Orcas. Sea lions. Commercial nets. Ocean temperatures shifting unpredictably as climate patterns destabilize. And yet, the salmon is not wandering. Studies tracking tagged fish suggest they follow thermal gradients in ocean currents with surprising precision. Some researchers believe the magnetic imprint made during early life now serves as a coarse GPS, guiding the fish across thousands of kilometers toward the general region of its birth. But magnetism can only get it close. The final navigation, the turn into the right river, the right tributary, the right gravel bed, will depend on something far more personal. The smell it memorized as an alevin. After 2 to 4 years at sea, something shifts. Hormones surge. The salmon stops feeding. Its body begins to change, hump forming, jaw hooking, skin flushing red. It doesn't know why. But it turns toward the coast. And the real test begins. The mouth of the Fraser River. Late summer. Stand on the bank here for a moment, and you can feel the river working against everything trying to move upstream. The sockeye salmon enters freshwater for the first time in years, and immediately, its body starts to fail. Kidneys that were built for salt must now flush excess water. Muscles that grew strong on ocean protein begin to break down. The fish will not eat again. Every stroke from here on is borrowed from its own tissues. And the river is not kind. The Fraser is one of the longest and most demanding salmon rivers in the world. From the coast to the spawning grounds, the fish may travel over 400 kilometers, through canyons, rapids, and stretches of water warm enough to kill. Predators wait at every bottleneck. Grizzly bears and black bears line the shallows, swiping at fish too exhausted to dodge. Eagles circle above. Sea lions patrol the estuary. And then there are the human-made barriers, dams, culverts, water diversions. Some rivers have fish ladders. Others have nothing. But the sockeye salmon doesn't stop. It leaps. Falls. Leaps again. Driven not by thought, but by a chemical trail, the scent of home, growing stronger with every mile. This is where olfactory memory proves its power. The salmon is not following a river, it's following a smell. And that smell is pulling it upstream like a thread through a maze. If the fish makes it, it will arrive at the exact stream where it was born, sometimes within meters of the same gravel bed. But here's the twist: if that stream has changed, polluted, dried up, redirected, the salmon may circle endlessly, unable to find what no longer exists. The map is only as good as the world it was made from. The spawning grounds. Early autumn. The sockeye salmon that left this place as a fingerling returns as something unrecognizable. Bright red body. Green head. Hooked jaw. Skin peeling. Eyes clouded. It is dying. And it knows exactly what to do. The female sockeye salmon digs a shallow nest in the gravel, a red, using her tail to move stones she no longer has the strength to lift. The male sockeye salmon guards her, fighting off rivals with what remains of his body. She releases her eggs. He fertilizes them. And within hours, sometimes minutes, both will be dead. But the story doesn't end here. The bodies of the salmon, thousands of them, begin to decompose along the riverbank. And in that decay, something remarkable happens. Nitrogen and phosphorus from the ocean, absorbed during years of feeding at sea, now flow into the forest. Studies have traced marine-derived nutrients in trees growing more than 100 meters from the water. Bears drag carcasses inland. Eagles scatter remains. Insects feed and are eaten. The salmon becomes the forest. The forest feeds the river. The river raises the next generation. This isn't just death, it's delivery. And buried in the gravel, under the same cold current, the next generation of sockeye salmon embryos is already beginning to imprint. The cycle doesn't repeat. It continues. So what pulls the salmon upstream? Not instinct alone. Not blind repetition. It's a memory written before the fish could swim. A smell carried across an ocean. A magnetic map etched into neurons. And a body willing to destroy itself to close the loop. The salmon doesn't return just to survive. It comes back to become something larger: food, fertilizer, signal, legacy. A bridge between ocean and forest, between one generation and the next. We call it migration. But maybe the better word is delivery. And somewhere in the Fraser River, right now, another sockeye salmon embryo is breathing in its first trace of home. If this journey made you see rivers differently, or wonder what other animals carry invisible maps inside them, leave a comment below. What surprised you most about the salmon's climb? Subscribe if you want to follow the next migration, across frozen tundra, where caribou walk a path they've never been taught but somehow always know.